Yes, if you could please state your name and if you're appearing on behalf of an organisation, which organisation? Thank you.
I'm David Close, on behalf of Origin Energy.
Thank you.
Stephanie Stonia, Origin Energy.
Thank you.
Alexander Cote, Origin Energy.
You might need to speak closer to the microphone.
Alexander Cote, Origin Energy.
Thank you very much. Yes, when you're ready.
Good afternoon, Madam Chair and distinguished panel. Firstly, on behalf of Origin, I would like to acknowledge the traditional owners of the land we meet on today and their elders, past, present and future. And we also acknowledge the traditional owners and pastoralists who have been hosting us and working with us in our permit area over the last 3 to 4 years. We appreciate the opportunity to present to the panel today and respond to the interim report, which we recognise as a really important piece of work in the inquiry process, and also respond, at least in part, to the panel's recent request for information. We also plan to submit a detailed written response to that recent request for information. We support the inquiry process and its importance in bringing certainty to the onshore gas industry. It's an industry that we believe could bring socio-economic benefits to remote communities in the Beetaloo area and surrounding regions, and also potentially bring benefits to the Northern Territory and Australia more broadly, as the Beetaloo does have the potential to deliver gas supply security and flexibility to the Australian gas market if it can be shown to be commercial. As, or more importantly, gas-powered generation is vital to the security and affordability of electricity supply as the Australian electricity market transitions to lower emissions energy sources. So the specific matters on which we'd like to present to the panel today are exploration and appraisal in the Northern Territory and the Beetaloo Basin in particular, groundwater baseline data, water use and reuse in hydraulic fracturing, well integrity and barrier failure versus well failure in particular, the development potential and compatibility with multiple land uses, stakeholder engagement and public benefits, and finally the need for objective or outcome-based robust regulations that avoid unnecessary prescription where possible. So across each of these areas we'll hear 3 important themes, consistent themes I think, that the Beetaloo could represent a genuine opportunity for economic growth without the need to sacrifice the Territory's unique environment or other industries. The critical need for exploration and appraisal to be allowed to continue so that more data to assess all aspects of the opportunity and minimise the need for assumptions to be used in these assessments. And the need, of course, for robust objective-based regulations and a clear and fair land access framework. I will now turn to the material that I think you're sharing amongst yourselves that hopefully you have access to.
Yes, we do. Thank you.
Where's the history? So Australia and many other countries saw an increased effort in unconventional exploration from the mid to late 2000s. Most of this effort in Australia was focused in Western Australia, South Australia and the Northern Territory. To date, unconventional exploration has not provided the technical success to suggest that outside of Queensland CSG resources, there is potential to replace the depletion of conventional resources. The interim report on page 35 quotes the 2014 Geoscience Australia study that reports approximately 12 trillion cubic feet of contingent shale gas resources. When Geoscience Australia update that in 2017, which I understand they're planning to, it will show a major downward revision in those contingent resources. And that reflects the changing perception of the Cooper Basin shale play in particular that would have been perceived differently in 2014. From 2006 to 2016, which is approximately the period this map represents, the NT did see a ramp up in the area under exploration permits or applications for exploration permits and in drilling activity. However, even during a time of high oil prices and following the shale revolution in North America that set very high expectations of an abundance of unconventional resources in Australia, the activity was still focused to 2 to 3 pretty discrete areas, led to approximately 25 wells being drilled, less than 10 of which were fracture stimulated. The Southern Georgina exploration, as an example, was the focus of a number of companies. It's the orange area on the map in front of us there. Ultimately, the exploration demonstrated a lack of technical prospectivity, and we are unlikely to see, in our opinion, the resumption of exploration for unconventional oil and gas in that play. It's effectively been technically sterilised. This is indicative of the exploration cycle where most exploration projects do not proceed to development due to some fundamental technical factors. Hence, despite the high proportion of the territory that is under an exploration permit or application today, it is our considered opinion that very few areas are genuinely prospective. The Beetaloo is one area that has seen sustained activity and encouraging technical results over this period. It is also the area where, outside of the Amadeus Basin, there has been the longest history of permits, with the area currently held by Origin being under permit almost continuously since the 1980s. The next slide shows a schematic illustration of a roadmap of the full exploration to development cycle, and it shows where we consider the Beetaloo to be on that path to a potential development. We and other operators are in the very early stages of an exploration and appraisal project. The project, as it's currently defined, includes 9 wells over a 5-year permit term. We've drilled 4 wells to date, with the moratorium preventing the completion of Year 3 activities. There are multiple stages illustrated here that precede a development decision, and they take quite some time, as is illustrated in the graphic, each of which involves a relatively discrete package of work that increases in scope and budget as the project matures, and each leads to a decision gate to either exit or proceed to the next stage of activity. There are also multiple levels of approval required to acquire production licences and development project approvals at both state and federal levels, and that's if all of the technical gates are successfully passed. We do hear the concerns that there is an impending rapid move to development from the current project status, which, when coupled with a substantial amount of the territory currently under permit, has created concern that the industry could grow and spread rapidly. We don't think that's a likely scenario given the number of potential factors that would limit that proceeding rapidly. The 67,000 well calculation by FrogTech, which was undertaken looking at any potential aquifer stress as part of the ACOLA study in 2013, has unfortunately been used to reinforce this perception, and we deal with this in some detail in our written submission. I'll refer you to there. So although we don't anticipate widespread potential development across the territory, we are encouraged by the results to date in the Beetaloo. Turning to the next graphic, it's a cross-section from across the Beetaloo Basin, not just Origin's permits. And this cross-section demonstrates a really important factor, that the positive technical results exist across much of the Beetaloo. This is critical for economic success, and it's also very relevant to the panel's request for information regarding the need to increase drilling intensity outside of a core area. So what this graphic demonstrates is that that core area can be quite large, and it would take a very, very substantial development to start to exceeding the core area. Now, we need more data to define what core area means over time and exactly whether there is a sweet spot and where it is, but the initial results from a relatively limited subset of data are encouraging to show that it is substantial in terms of area. The other thing to note is that the target intervals, particularly what we refer to as the Middle Valkyrie B shale, which is highlighted in the cross-section, is relatively concentrated in terms of thickness. This is ideal for containment of fracture height growth and also in terms of resource concentration, both of which are critical factors for the successful horizontal developments. So really positive data from, as I said, a relatively limited subset to date. So although largely focused on the Valkyrie formation to date, the Kyla formation remains of technical and potentially economic interest. It is likely rich in natural gas liquids and condensate that are in a gas phase within the reservoir but can be extracted changing the pressure or temperature conditions. Such liquids or condensate would improve project economics substantially. The Kyla formation is explicitly addressed as a potential target in our earlier submission to the inquiry. Our comments regarding the vertical separation are equally applicable for the Kyla and Valkyrie formations. As the panel are aware, Origin drilled the first horizontal well in the Beetaloo in 2015 and fracture stimulated and tested that well in 2016. The results of that well, the Amungi W1H well, prompted the declaration of a discovery to the Northern Territory Government and to the Australian Stock Exchange, and subsequently the recognition of a contingent resource. The contingent resource booking is a pretty important milestone in the basin, but it is not, as referred to on page 7 of the interim report, known that there are economically viable shale gas deposits in the Beetaloo. This is a really important distinction between a contingent resource booking and a reserves booking. So contingent resources are, by definition, only considered to be commercial contingent on some other factor, for example, either market or price or some technical factors. They are confirmation that a technically recoverable resource that could potentially be commercial exists. So we're confident to make that statement, but we aren't confident to say that at this point we know that it could be commercial. The exploration campaigns to date have largely de-risked the volume of the resource, as I've discussed, but there is still a substantial amount of work required to convert to reserves. Most importantly, from a reserves perspective, we don't know yet what a most likely estimated ultimate recovery or ultimate recovery per well and a per well cost will be. If the Beetaloo is commercial, though, the consistency of the quality of the reservoir that we've seen in the reservoir in the cross-section and the map area over which it is known are likely to be able to provide a long-term flexible gas supply option for domestic and export demand. We understand that a critical aspect of any project proceeding to development in the future will of course be environmental approvals, and having appropriate environmental baseline data to seek such approvals will be critical. Almost immediately upon becoming operators of the permits in August 2014, Origin began our groundwater monitoring program. We have submitted detailed information regarding our program previously and provided the 2014 desktop study that our program builds upon. As we've stated previously, our program exceeds the regulatory minimum and we have installed additional monitoring at all wells. There has been some commentary to the panel about the hydraulic conductivity of the Cambrian limestone aquifer, and we do expect that the Cambrian limestone aquifer in the Beetaloo area to have a high hydraulic conductivity, but our data and existing data show that a relatively low hydraulic head across the area, so the transmissibilities will typically be lower. Our operations at the Amungi and W1H well in 2016 allowed us to acquire data from a relatively localised area. In total, about 10 to 11 megalitres was extracted from the Cambrian limestone aquifer over a period of approximately 5 weeks. Logger data from the extracting water bores, as in this chart, shows how rapidly drawdown returns to 0 metres after pumping ceases. The chart also shows the water level in a monitoring bore approximately 3 kilometres away, the green line, from about 3 kilometres from the lease. During that entire extraction period, it shows no change in its water level. So these data show that in this area, the Cambrian limestone aquifer has the potential to supply substantial volumes without impacting the aquifer level or deliverability even in a localised area. And we'll be sharing these data in the written submission. Origin are already collaborating with other operators and CSIRO to expand the collection of baseline data, and this expansion is being managed by CSIRO very much at arm's length from the operators. Our expectation, if activity is permitted to continue, is that our baseline data acquisition will expand to include other aspects of the environment. Origin does undertake some of its own baseline studies in its areas of operations, but we also support independent studies through universities and research organisations. Establishing the location and extent of any fugitive emissions that currently exist as landscape emissions in the Beetaloo is obviously of critical importance to Origin prior to development and would be a priority for us over the coming years. Likewise, understanding the baseline air quality and biodiversity is critical. We will provide further commentary in our written submission regarding potential methods to complete appropriate baseline studies. And we propose that such baseline studies are appropriately commenced in parallel to ongoing small-scale exploration appraisal. Data from such exploration and appraisal will be critical to inform the geography of the appropriate baseline studies at a minimum. I'll now hand over to Alex to discuss water use in an unconventional development and well integrity.
Thank you very much, Dave. Good morning, good afternoon, Madam Chair and distinguished panel. Thank you again for the opportunity to speak today. Origin recognized the importance of groundwater usage, groundwater resources, and the importance of proper management around those resources. Assessing water requirements for shale gas development in relation to an area's sustainable yield is an important task, is an important undertaking and one that we are progressing. The risk of stressing the CLA groundwater resource in the Beetaloo Basin, we believe, is remote. Research estimating the sustainable yield from the CLA in the Beetaloo area highlights that the CLA is currently underutilized and could easily support the additional draw from a shale gas industry. It is estimated that the sustainable yield of the CLA in the Beetaloo area is in excess of 100,000 megalitres a year. Current usage estimates are currently at about 6,000 megalitres a year. A 1,000 to 1,200 well development scenario, as described in the interim report, would require 5,000 megalitres per year at peak demand, assuming no recycling of flowback water. Even without accounting for recycling, this would mean that only 11% of the estimated sustainable yield is required to support both the pre-existing and the peak shale gas water demand. Given that there is an order of magnitude difference between the forecasted water demand and the estimated sustainable yield, the risk of overusing or overallocating the CLA as a result of a shale gas development is low. In addition, water levels are and will continue to be monitored and assessed at both a local and regional scale, ensuring the sustainable management of the resource. Origin also supports quotas and good regulatory framework around the management of the water resource. Next, I'll move on to recycling. Sourcing, recovery of load fluid, recycling, and disposal of that fluid are all inextricably linked. The ability to recycle flowback water to use in subsequent hydraulic fracture stimulation operations reduces the amount of water that needs to be sourced and, in my mind, more importantly, the amount that needs to ultimately be disposed of. The Beetaloo does not have readily available disposal options. Frequently used disposal options for hydraulic fracture stimulation fluids includes disposing of the flowback water into depleted reservoirs using injection wells, or quite commonly used in enhanced oil recovery operations, neither of which we really have across the Beetaloo area. So it is unlikely that these options will be valid options in the region. Without such options, recycling offers a promising solution. Other areas with limited disposal options, such as the Marcellus, have demonstrated recycling rates approaching 100% of the recovered load fluid. I know the panel has been discussing the difference between load fluid recovery and recycling. So load fluid recovery is the amount of fluid we get back from what we put into the wellbore. The percent of load fluid recovery varies substantially from shale play to shale play. It can be as low as 10% and in some areas exceeds 90%, so it's quite variable. At Amungi, 18% of the load fluid was recovered by the end of the production test. We estimate that approximately 30% of the load fluid would be recovered if we had continued to produce the well. The Amungi values are a single data point, and it's too early to know what the expected load fluid recovery on average for a well in the Beetaloo might be. And this is also subject to change depending on factors such as what the go-forward hydraulic fracture stimulation fluid might look like. For example, at Amungi, we used a hybrid system, whereas go-forward, we might look at using slickwater systems. And this could have an impact on what the recovered load fluid percentage could be. The recovered load fluid at Amungi was sampled and analyzed. The flowback fluid is primarily a brine with a limited number of geogenic components, relatively low norms in comparison to North American shales, and low BTEX values compared to North American shales, in line with BTEX values we see in CSG flowback. Origin will be submitting the analysis of the flowback fluid, along with a comprehensive risk assessment that assesses both the components of the hydraulic fracture stimulation fluid and the geogenic components as part of the written response. Our analysis indicates that the flowback fluid would be suitable for reuse in subsequent hydraulic fracture stimulation operations, and that we could expect to achieve a recycle rate in the range of 90 to 100%. In order to recycle water for hydraulic fracture stimulation use in a development scenario, in-field storage will be required. In order to limit the amount of storage required, Origin, like Santos, would plan on operating year-round during a development scenario. It was suggested at a panel session last week that Origin would not operate or hydraulically fracture stimulate in the wet season. Though it is true that we have avoided drilling and hydraulic fracture stimulations during the exploration phase to date, this has been primarily for logistical and civil engineering requirements. For example, all-weather roads in the Beetaloo would be prohibitively expensive during an exploration phase. In a development phase, this changes. At the last panel hearing, the panel requested that Origin comment on the contamination of groundwater as a result of activities associated with hydraulic fracture stimulation operations, and in particularly in relation to the 2016 EPA report. The EPA report is comprehensive and follows the entire hydraulic fracture stimulation water cycle, from acquisition to reuse and disposal. The modes of potential environmental exposure can be categorized into surface releases during chemical mixing and produced water handling stages, and induced pathways during injection and production stages. I will summarize the risks and factors that affect the frequency identified by the EPA before relating it back to the Beetaloo. I'll begin on the surface side with chemical mixing and surface handling. As outlined in the EPA and the interim report, spills are a challenge for the industry, and there have been spills that have reached soil and surface water receptors. In the EPA report, they identified and analyzed 36,000 spills reported between 2006 and 2012. Of these, it is important to note that only 151 were associated with hydraulic fracture stimulation operations. Of the spills associated with hydraulic fracture stimulation operations, the majority of these occurred due to either equipment failure or human error. Origin takes the risks of spills seriously and applies a three-tier barrier philosophy to prevent spills from reaching or impacting ground or surface water resources. The first barrier is spill prevention. This is all about testing and maintaining the integrity of the system. The second tier is spill containment. Systems can fail, and humans will make mistakes. For this reason, we use secondary containment. The third is to be prepared to remediate in the event of the first two barriers failing. If a spill were to occur in the Beetaloo, we're fortunate that the depth of the aquifer and the barriers presented by clay layers between the surface and the aquifer, along with being prepared, so a short response time, reduces the likelihood of a spill reaching and impacting groundwater resources in the event the first two barriers fail. I will now move on to issues associated with fluid migration in the subsurface. The EPA identified two potential induced pathways for fluids to migrate between hydrocarbon-bearing zones and drinking water resources: fluid migration pathways along the production well, and fluid migration associated with induced fractures within the subsurface. The primary factors discussed by the EPA that can affect the frequency or severity of groundwater impacts as a result of induced conductivity are the construction and condition of the well that is being hydraulically fracture stimulated, the amount of vertical separation between the production zone and the formation that contain drinking water, and the location, depth, and condition of nearby wells or natural faults or fractures. Firstly, I wanted to review a special case that was highlighted in the EPA report. There are very few instances of complete loss of well integrity during pumping operations. However, such an instance did occur in Killdeer, North Dakota in 2010. The well completely lost integrity during pumping and resulted in a 2,000 barrel release of frac fluid into the environment. Though this was the first incident to lead to a release as a result of complete loss of well integrity in North Dakota, data would indicate that at least there were five prior incidents of where a barrier had failed during pumping. The cause of these incidents in North Dakota can be contributed to several factors: inadequate casing design, inadequate pressure testing, an undefined safe operating envelope, and inadequate regulatory review. At the well that failed in Killdeer, the pressure relief valve was found to be improperly set to well above the pressure to which the well had been tested to. The regulator, though requiring pressure testing to be conducted, did not review and validate the pressure test on all occasions prior to allowing hydraulic fracture stimulation operations to commence. This incident brought about changes in the North Dakota regulator. Since the Killdeer incident, the North Dakota regulator now reviews all the pressure tests prior to issuing approval to hydraulically fracture stimulate a well. There have been no reported incidents since. I believe this is also a good demonstration of industry, one, sharing their lessons between various regulatory regimes in North America and between operators and service companies. Typically, when there are large-scale incidents, industry typically, along with regulators, reacts swiftly. I would like to comment about the process at Amungi, as it will be different than that was experienced in North Dakota. Pressure testing prior to hydraulic fracture stimulation operations is both an internal requirement of Origin and a regulatory requirement in the NT prior to any hydraulic fracture stimulation operation. Pressure testing was conducted prior to stimulation at Amungi. The system was tested to 10,000 psi. The pressure test was not only reviewed by Origin, but the regulator as well before being issued approval. The pressure test is an important test as it is used to define the safe operating envelope during our stimulation operations. The most important limit that the operating envelope defines is the maximum allowable pumping pressure. The maximum allowing pumping pressure at Amungi was set to 9,300 psi to maintain a safety margin. To ensure that this was not exceeded, each hydraulic fracture stimulation pumping unit had an automated high-pressure shutoff control, as well as a pressure relief valve that was installed on the surface treating lines that would prevent a pressure from being exceeded above the maximum allowing pumping pressure. I will now move on to their comments about well construction and stray gas migration. The well injection section documented occurrences of where stray gas migration led to increased methane concentrations in aquifers. The EPA has included the production stage of the well's life cycle with the relatively short injection stage in their report. I believe this can cause some confusion, as it would suggest that these incidents are often associated with pumping operations. Firstly, the EPA is correct in their assessment that poor well construction can lead to an increased likelihood in stray gas migration. However, the challenge of preventing stray gas migration is irrespective of whether the well is conventional or unconventional, fracture stimulated or unfracture stimulated, vertical or horizontal. The examples provided in the EPA report included Pavilion and the Wattenberg field. Neither of these plays are shale plays, and many of the wells associated with stray gas migration in both of these plays were unstimulated. Stone et al. From Colorado School of Mines conducted a study on the failure rates of wells in the Wattenberg field in Colorado. They grouped and ranked common vertical, deviated, and horizontal wellbore barrier designs based on risk of multiple barrier failures, which is presented, the table presented on this slide. On the left-hand side of the slide, you'll find a well is a category 1 well associated with the table, and on the right-hand side is a well that is a category 7 well. You'll see that there's a substantial difference between the design of those two well bores. Further, to put this into context, Origin's internal standards would require a well to meet category 6 requirements at a minimum during production operations, and at least a category 7 requirement for well abandonment. The design of Origin's Beetaloo wells align with category 9 requirements, which has an even lower risk profile than the wells in the Stone et al. Study. The next slide includes a table of the results of their study. The study shows the wells with appropriate surface casing and cement tops, category 6 and 7, have seen no failures in the field to date, regardless of their orientation. These findings are repeated by the Environmental Protection Authority. These two primary causal factors of aquifer contamination resulting from fluid migration pathways within and along the production well, which are inadequate surface casing depth, that is, the casing is not set below the aquifer, and inadequate top of cement, that is, the cement is not set above the shallowest hydrocarbon-bearing zone. In the Wattenberg field, you can see how operators have responded to this challenge over time. The chart shows the trends of where surface casing has been set and where cement tops are. You can see that over time, operators have been continuously setting their surface casing deeper to handle this challenge, and their top of cement is higher. Unsurprisingly, this trend aligns with the elimination of new stray gas migration cases caused by new wells seen in the Wattenberg field. For stray gas to occur, you need a hydrocarbon-bearing formation, a pathway, and a drive mechanism. If we make the assumption that a pathway is present, let us quickly investigate the ability and likelihood to migrate hydrocarbons or other in situ fluids from where they currently reside to an aquifer in the Beetaloo setting. The potable aquifers that we are interested in protecting from stray gas or fluid migration are all relatively shallow in the Cambrian. Factors that will affect the ability for a fluid to migrate include the transmissibility of the formation, pressure differential between the reservoir and the aquifer, and lastly, the fluid density. Transmissibility is how easily a fluid flows through a porous medium. Formations that are of considerable concern are high permeability formations with low viscosity fluids. These pose the highest threat. Fluids are lazy. Even if a migration pathway exists and there is sufficient transmissibility, this does not mean a fluid will move. A fluid will only move if there is a drive mechanism. That is, it needs to move from a place of higher relative potential energy to a place of lower potential energy. What this essentially means is the formation you are leaving needs to have a higher pressure gradient than the formation that you are traveling to. Lastly, there is density. Density is important to consider because different fluids have vastly different densities. For example, gas is buoyant in oil or water, allowing it to migrate easier if a pathway were to exist. This is why gas is far more likely to migrate than brines or other liquids. The brine-bearing formations in the Beetaloo are the Bucalorkme and the Maroc. The formations are permeable, and the formations can flow brine if the bottom hole pressure is dropped. However, their estimated potentiometric surface is below the aquifers. This implies that there is insufficient energy to move the brine to surface or to the CLA if there were a pathway present. Origin have identified 3 hydrocarbon-bearing formations: the Chambers River, Kyala, and Valkyrie. That is not to say that there aren't more in other areas within the Beetaloo that have yet to be explored, but those are the ones that we've identified to date. The Chambers River sandstone is the shallowest and is likely oil-bearing. It has been tested several times on DST, but the transmissibility and the pressure were too low to flow the formation. The formation is thought to also be normally pressured. As a result of the capability for this fluid to as a result of it being normally pressured and relatively tight, the capability for this fluid to migrate to an aquifer is low. The Kala and the Valkyrie are likely overpressured and therefore have the ability to migrate to a low-pressure formation such as an aquifer if a pathway were present. It is important to note, though, that the permeabilities of both formations are very low, in the nanodarcy range. Therefore, the rate at which gas would be expected to migrate would be very low. The Beetaloo does not have some of the same challenges of permeable gas-bearing zones that pose the large threat to stray gas migration. However, this does not change our well design or construction philosophy, which is not to provide a migratory pathway in the first place. Just to reiterate, when designing and constructing a well, Origin knows where the aquifers and hydrocarbon-bearing formations are. We ensure a minimum of 2 barriers across the aquifer, and we ensure that any casing string that cases off a hydrocarbon-bearing zone, irrespective of whether it's a production target or not, is cemented to surface. The EPA noted that older wells exhibit more mechanical integrity problems compared to newer wells when hydraulically fractured or refractured. Origin completely agree with this assessment. However, it is not applicable to the Beetaloo as there are no legacy wells that we would re-enter and hydraulically fracture stimulate. The EPA identifies the importance of vertical separation between the target formation and aquifer. In areas where there is little or no vertical separation between the production zone and drinking water resources, there is a greater potential to increase the frequency or severity of impacts to drinking water quality. The plays where this is an issue are typically shallow CBM formations, such as the Black Warrior, Powder River, and Raton, when there can be little or no separation, as documented in the EPA report. The practice of injecting hydraulic fracturing fluids into formations that also contain a drinking water resource can also affect the quality of that water, because it is likely that some of that fluid will remain in the formation following hydraulic fracture stimulation. An example of where this has occurred is the Wind River Formation in Wyoming. However, these examples aren't exactly relevant to the Beetaloo, given the offset and the fact that neither the Valkyrie or the Kyla are an aquifer. The EPA identifies elevated risk levels of hydraulic fracture stimulation fluid migration to the aquifer in the presence of active, suspended, or abandoned wells as well. Again, these risks are low in the Beetaloo. There are very few abandoned wells across our permits, and we would plan on simply avoiding them by maintaining an adequate offset around them. In the future, if a development does occur, hydraulic fracture stimulation operations will occur in the vicinity of producing wells. We believe these risks can be managed by following guidelines such as Alberta's Energy Regulators Directive 83. The EPA also comments on the elevated risks around faults. However, it is important to understand that not all faults are created equal. There are very few large-scale geological features within the proposed development area of Origin's Beetaloo permits. Most faults are interpreted to be subseismic, sort of between 25 and 50 meters in offset, and contained within a particular formation. These faults are not of concern. In the permits, there are very few through-growing faults that penetrate from the Valkyrie to the shallow subsurface. Large faults, most likely located towards the edge of the basin, would be deliberately avoided as they increase the risk and cost of drilling and hydraulically fracture stimulating the well. These include the risk of sidetracking and the risk of screenouts. Next, I'll comment on well failure statistics. Ingraphia claims that well failure rates in the Marcellus are between 7 and 9%. These well failure numbers have been commonly cited. Analysis of the source data, however, suggests that failure rates reported by Ingraphia are overstated. This is of importance because the numbers are used to directly represent well failure and releases to environment, not as an indirect measurement or proxy. Ingraphia's analysis of Marcellus well failure rates relies on notices of violation issued by the Pennsylvania Department of Environmental Protection, PADEP. Firstly, I applaud the use of this data to assess industry and encourage it. I believe that you can't manage what you don't measure, and that many good insights can be taken from the data, and that the data can be used effectively not only to assess loss of well integrity, but also leading indicators such as barrier failures. However, semantics become important here. The loss of integrity of a barrier should not be conflated with the loss of integrity of a well. A loss of well integrity occurs when enough barriers have failed to allow a leak path that could result in a contamination. Many of the notices of violation categories included by Ingraphia imply a potential barrier failure, but not a loss of well integrity. The notices of violations associated with potential well integrity failures were often issued preemptively during design and well construction phases. That is, before any well integrity failure could occur. It is also important to note that PADEP has been commended for their effective and robust regulatory framework, in particular with respect to hydraulic fracture stimulation by the State Review of Oil and Natural Gas Environmental Regulations. I believe that is a sign of a well-functioning regulator that issues preemptive notices of violations when minimum well construction requirements are not met. 97 of the 473 wells that Ingraphia claimed failed did not even receive a notice of violation, but the basis of failure was made from commentary in the inspector's report. In these cases, there is insufficient data to conclude that there was a well integrity failure, and the absence of a notice of violation state that there likely was not one. PADEP also requires that operators rectify notices of violation through remedial work. The majority of the NOVs issued by TADEP had been corrected by the operator in order to comply with the regulator's requirement. Again, this was not accounted for in the Ingrafia paper. Ingrafia's data also only extends to 2012. Based on the PADEP NOVs data compiled by Origin, the number of NOVs on average has declined year on year. Again, we believe that this is likely a function of a good regulatory framework managed by PADEP, resulting in operators that are aware of the regulatory expectations. All the raw data would have been included in our initial submission. Lastly, I want to touch on abandoned wells, as again, they're of interest to both the community and the panel. Other than leaks at surface or contaminants found in aquifers, it is difficult to actively assess a suspended well, as it can't be re-entered. What I will say is that the risk of fluid migration in the Beetaloo at virgin conditions is low. The producing zone at the time that a well is suspended or abandoned will be depleted, and it will therefore lack the energy to move fluids out of the primary reservoir into an aquifer. In addition to this, I would state that there have been over 4 million wells drilled in North America, over 1 million alone in Texas, and over 400,000 in Alberta. Though there have been incidents associated with fluid migration, stray gas migration, there has been no systemic problems reported or observed. If the risk around abandoned wells was truly problematic or systemic, the issue should have manifested itself already and be easily observable in North America. The map behind you shows that there are large areas with over 1,000 wells per 100 square miles. So we're talking about intense activity that has occurred over 100 years of drilling now. And now I'll hand back over to Dave.
Thanks, Alex. I'll move on to just discussing a bit more about the economics of shale gas more generally. There are many ways to demonstrate the economic success of the US shale gas industry. Gas price is probably the best measure. The US has sustained low gas prices since the expansion of the shale gas industry, with historically low levels of drilling rigs active, which is what the chart in the upper left shows. So with very few wells managing to maintain high productivity and keep prices low. This low price is somewhat a penalty of success for the US shale gas industry. It's made it a very competitive industry. The US experience demonstrates that shale gas is not necessarily a high-cost source of gas. Arguably, US shale gas is the cheapest source of gas on Earth. So I think that's a really important takeaway for us in the Northern Territory. It wasn't predictable at the outset of the US shale revolution that this would be possible. They needed a solid data set of plays and wells to prove it. And it's a cautionary tale for any economist or analyst that claims to foresee the economic potential of similar opportunities in the Territory. It's simply too soon. In the chart in the lower right, you'll see that in 2005, production from shale gas was negligible, and it has grown over time to be over 45 billion cubic feet, much more than 50% of the daily production. And the Marcellus now exceeds the federal Gulf of Mexico as being the number one gas supplier into the US. It is yet to be seen if this experience can be emulated, either in Australia or internationally, but there are insufficient data to show that it can't. At the core of this economic success are the efficiencies of horizontal pad developments. These efficiencies are realised both in the subsurface and at the surface. The montage of maps and aerial photos on the next slide shows a reasonable analogue for what surface impact could approximate in the Beetaloo. These images are from eastern Ohio, where over the last 5 to 6 years, the Utica shale play has emerged. This particular area has not previously had conventional oil gas developments, which is relatively rare in the US in areas where unconventional plays have evolved. In these images, the relatively limited surface impact is clear. The lack of existing infrastructure related to conventional developments is similar to the Beetaloo, obviously. In the Beetaloo, Origin has access to large, continuous land tracts as part of our permits, and therefore can optimise development and avoid the patchwork-type developments that can occur in some areas in North America, where operators have limited continuous land access. The next slide shows an example of what the Beetaloo will not look like. The Beetaloo will not look like West Texas or South Texas. This image or similar images are used by those opposed to onshore gas to imply something that is not reasonable and would certainly not be economic. The stratigraphic chart that I've included, that is from this same area where the photo is from in South Texas, and the stratigraphic chart is from the USGS, shows that there are more than a dozen oil and gas targets in this area, and there is decades of development of both oil and gas from different reservoir levels. The recent Eagle Ford Shale pad development is not the primary contributor to the development in this area. It should also be noted, though, that across South Texas and much of Texas, ranching of cattle and oil and gas developments coexist successfully, and that tourist attractions and recreational hunting operations in the area continue to operate successfully and have done so for decades. So even in areas where this kind of development is the norm, it has not impacted the other industries unnecessarily. In the next slide, we talk about we show the development scenario outlined in our written submission. It includes approximately 400 to 500 wells on 50 to 65 pads over a 20 to 30 year period. The pad spacing of this development is asymmetric, and it's a function of well length and regional stresses. This is relevant to the recent request for information regarding a minimum spacing of pads. The number of wells and pads in a development is a function of a number of factors: technology, how far we can drill, the EUR per well, what the market looks like, what the access to market, i.e. the pipelines that exist. More data are needed to provide a more detailed development plan. We don't support a prescriptive minimum pad quantity or spacing. There could be very valid surface constraints that impact pad placement decisions, and the objective should be the overall impact minimisation, both on the environment and on other land users. On the varying well number estimates that the inquiry may have received, we would put that such estimates can be built with different assumptions. Different proponents may model well results the same, but overall demand differently, or vice versa. The primary economic drivers, however, will be similar, and they are primarily the estimated ultimate recovery per well, the liquid yield from the gas stream, and the cost per well. And again, we reiterate that the US experience should provide pause to any person that claims to know the Beetaloo or other territory plays are not economic. On cost, it's important to note that no optimised development would include infill drilling or refracturing. Such activities would typically worsen economics if it was in the same play. A success case would create supply diversity and critical flexibility. And a little bit on that, can it be successful? The next table, I will not attempt to go through every row, it's pretty dry. But what I would point out that a number of key technical factors, the Beetaloo does compare favourably to successful plays in North America. I think that's worth noting. Of course, there are still further technical data required, and as well as the technical data required, there are numerous non-technical challenges that remain. And I'll hand over to Stephanie to talk further to some of these issues.
My name is Stephanie Stonia and I'm Origin's Corporate Affairs Manager for Northern Australia. Based in Darwin, I support our exploration assets both onshore and offshore in Northern Territory and Western Australia. Today, I will comment briefly on a small number of elements in the interim report. Our observations will also be included in a written response to the report and the most recent RFI received from you, Madam Chair. Firstly, we'd like to acknowledge and thank the Chair, the Deputy Chair and the panel members for their work to date. The interim report has comprehensively looked into both the perceived and actual risks of impacts of our industry, and we consider the report to be a fair and reasonable representation of the current state of community sentiment in the Northern Territory. We pay particular respect to the extensive community consultation that has been undertaken. We see this particular component of your work as holding high value. As operators conducting small-scale activity in a discrete area, we have to date limited our interactions to our directly impacted stakeholders. We have not sought to enter communities where we do not operate, nor have we sought to go into communities in the absence of an invitation to do so. On this note, we would like to share with you our approach to stakeholder interaction relating to our 9 exploration wells, as per our commitment to the Northern Territory Government required under our 5-year exploration work program. Whilst we agree that there is more that industry can do to share information more broadly with communities further afield from where work is being carried out, for our directly impacted stakeholders, we believe we have strong local support and partnerships. Origin believe it is important to understand and employ different types of stakeholder interactions at the appropriate time in extractive projects' exploration to production life cycle. These important differences we distinguish between and describe as communication, consultation, and engagement. Communication in the current context and in the point in time of our project, we treat as the transfer of information about an actual or proposed activity without an expectation of a direct response. Communication we refer to as a push process. Consultation we see as the provision of information whereby we are seeking responses to an actual or proposed activity. Consultation is a two-way process. An engagement we consider as being an exchange of information where related parties listen to concerns and suggestions. It is the approach which provides for co-design of an actual or proposed activity. Engagement is a process of active consideration of any concerns and suggestions about the design, execution, and operational parameters. It is a two-way process involving a business-to-business relationship that incorporates the concerns and requests of co-land users in the planning, executing, and ongoing management of activities. Collectively, we refer to these suite of stakeholder approaches as stakeholder interactions. We believe it is of vital importance to understand the purpose of each of these and how we afford, at this point in time, strong weighting to our co-land users and landholders. We are, of course, each other's directly impacted stakeholders. Since Origin began operating in 2014, our exploration permits Since Origin began operating in 2014, our stakeholder interests have been primarily focused on engagement with our directly impacted stakeholders. To be clear, we refer to those as our host traditional owners, our host pastoralists, the local business owners in Daly Waters, and the Northern Territory Government. We consider this area of stakeholder focus at this point in time in our project to be correct and to be correctly weighted. Given that, one, it is only by working collaboratively with these business partners can we jointly realise the opportunity of our exploration acreage, by being able to conduct the necessary work that secures the data to then be able to communicate and consult more broadly into the region and across the Northern Territory. And two, it is aligned to the scale and level of impact of our activity, which to date is 4 exploration wells from 3 well site locations. With the above stakeholder interaction context provided, I now turn to specifically addressing an element in the report on page 6, where I quote, "It is the panel's assessment that Aboriginal people have not been given enough information about the potential risks and benefits of hydraulic fracturing. It is imperative that accurate information is provided to Aboriginal groups likely to be directly affected by hydraulic fracturing well in advance of any decision being made." We agree with this statement. However, we also offer that for the Aboriginal people who are host traditional owners with the rightful cultural authority to make decisions in relation to what does and doesn't occur on their land, have engaged consistently with us and have a good understanding of exploration activities, culminating in their consent for each exploration well which has been executed. Origin follows the prescribed process of engagement with traditional owners, both through and with their statutory representative body, the Northern Land Council. Moving through the interim report to page 119, where again I quote, "There can be no doubt that the absence of the right to veto at the production phase places traditional owners in a difficult position at the exploration phase, which is the only point at which they can exercise their veto right, because the information that is available with respect to production at the exploration will be very limited. Our exploration acreage does not fall within the land tenure boundaries of the Aboriginal Land Rights Act. So whilst this observation may be accurate for exploration permits or for mineral resource projects on Alba land, This statement is not universally accurate for permits on native title or Aboriginal freehold land. Exploration agreements are in place between traditional owners, the Northern Land Council, and operators, which provide consent for exploration activities only. Clause 11 of our exploration agreements, we have two and a tripartite agreement, and associated subclauses prescribe that consent is required for any and all production activities, not the least of which is that a production agreement must be in place prior to development activity. Origin is mindful and respectful of the confidentiality clauses in these agreements, and we respectfully request or suggest, Madam Chair, that you seek the support of the Northern Land Council to assist you in securing consent from the exploration agreement parties for you to be provided copies as evidence that traditional owner consent is required prior to production. With regard to pastoralists hosting Origin's exploration and appraisal activities on their leases, we would like to resubmit and confirm that we have not conducted activities on any property that our acreage shares with other land users, whereby we have not reached an access and compensation agreement prior. This is the case for our 3 well site locations, as well as negotiating access and compensation agreements where infrastructure such as airstrips and roads may cross or be located on another station or another property. The existing guidelines provide that the Minister will not approve an application for activity in the absence of pastoralist consent. Origin support this guideline provision being legislated with the appropriate dispute resolution pathway being understood and accepted. The last decade has seen an increased focus on the onshore sector of the industry, and as we learn to share and co-use land to yield maximum benefit from the natural resources both at surface and at subsurface. Origin's surface footprint of a notional development in the Beetaloo describes approximately 50 to 65 140 metre by 140 metre well pads, which would take approximately 20 to 30 years to install. What we seek to illustrate here is that a notional shale gas development is not of the scale nor nature that would be detrimental to other land users. Nor do we consider that would remove or dilute any other industry's ability to continue to operate and contribute to the NT economy and provide Northern Territory jobs. Primarily in our prescribed area in the Beetaloo, this statement refers primarily to cattle and to a lesser degree the agriculture and tourism industries, which are more prevalent to the north of where the prospective gas basin is. We consider multi-land use as being a sustainable model that could deliver collective net benefit to the Northern Territory. This view aligns with the Queensland Gasfields Commissioner's finding in that landholders are key business partners that enable natural resources to be developed on behalf of the state and the community, and that there must be mutual knowledge of and respect for each other's business. It is our view that this is an accurate statement that acknowledges the fact that there is a property right and a subsurface resource right, and that each carry important value and merit for the community as a whole, and that one should not be treated as superior to the other. The business-to-business commercial arrangements between multiple land users should be allowed to flourish between the affected rights owners. Providing a veto right for one over the other or regulating to prevent access to resources like water or gas does not honour the fundamental principle of equality in rights. The Commissioner also recommends that industry must engage early with local government to help counteract its initial community impacts and build a stronger future together. Origin committed in its first appearance before this very panel that should we arrive at a point where an economic and sustainable development is a proven proposition, we commit to working collaboratively with community and government in advance of such a development. The Commissioner also strongly encourages that discussion, engagement and decision-making about all aspects of the industry, its impacts and its benefits be grounded in factual information and not in emotion. Especially the sciences of geology and water, where there is contradictory information being distributed throughout the community. Perhaps this type of work relating to the provision of factual information could fall within the remit of an independent NT Gas Commission. Origin consider it prudent to invest in and establish a dedicated body as soon as possible with a clear role in facilitating interaction between industry and community, where all parties are held to account for their information disclosure and content. Perhaps this will assist in reducing the non-factual information in the community, which is a genesis in some areas of substantial stress, divisiveness and a concern. We continue to be encouraged by the opportunity that a safe and sensitive development in the Beetaloo presents for growth in Northern Australia, though we must responsibly reaffirm our previously stated position that it is critical for further exploration and appraisal activities to be carried out. It will allow operators on behalf of the Territory to gather the data sets that will ensure that it is factual information that guides policy and decision making. The substantial body of data collection work obtained through each stage of exploration, appraisal and delineation must be undertaken before any development sanction could be considered. Any delays in undertaking this work further defers the economic opportunity for the Northern Territory. We maintain that a development in the Beetaloo could deliver both direct and indirect jobs, provide economic stimulus through private investment, and return a royalty revenue to the Northern Territory. The Northern Territory's natural gas resources could furthermore potentially underpin energy security in Australia for decades to come. We take seriously the environmental and multiple land use concerns of stakeholders. We are committed to understanding these issues and demonstrating safe and responsible operations in order to assist in building community confidence and trust in our commitment and our capability at identifying, managing risks and executing activities safely. Should this scientific inquiry find that hydraulic fracture stimulation can continue to be executed safely, we do not support the following. We do not support a prescribed and limited season of operation. We do not support a right of veto. And we do not support prescription on well pad spacing and separation. Whilst the existing legislative and regulatory framework in the Northern Territory continues to serve and be appropriate for the current and future exploration activities, we do, however, support fit-for-purpose improvements which align the regulation to the geology and scale of an unconventional gas play development in the Beetaloo. Some examples include that Origin support a holistic water management regime for the Northern Territory whereby all industries and users report their usage, that we support the legislating of the current guideline which provides for landholder consent being obtained prior to the Minister approving applications for activity. We support improvements such as codification for well integrity. And we support the concept of exclusion and or no-go zones with acceptable buffers for the explicit purposes of protecting national parks, sacred sites and sites of cultural significance, to name but a few. We cannot understate that it is continuance of prescribed exploration and appraisal activities regulated under the existing Act and regulations which will allow collected data to scientifically confirm the technical assumptions of the size of the play in terms of recoverable gas. It will provide inputs that can inform the economics of the resource based on volume, rate and composition of gas. It will provide factual information and data to design what an actual development could be, replacing the current situation of only notional development scenarios. This data would inform actual risks and provide for the design of appropriate and specifically engineered controls to mitigate, manage or remove those risks relevant to the specific science of the prescribed geology and water profiles in the Beetaloo. And it will meaningfully inform the type and nature of recommendations that will help build a fit-for-purpose regulatory regime in the Northern Territory. We have endeavoured to touch today on a range of issues highlighted in either your interim report, the most recent RFI, and or material presented before this inquiry during the public hearings. We thank you, Madam Chair, and the panel for the opportunity to appear before you again and be able to present our information and observations. We would be pleased to take your questions.
Thank you very much. Thank you very much for your detailed presentation and further information provided upon request to the inquiry. I just want to get one thing clear, and it just goes to show you shouldn't always believe what you read in the paper. the seasonal operation restriction, what exactly are you not supporting and what you are supporting? Because there seems to be some confusion.
I'm happy to take that, Alex, and you want to add to it. At the moment, we've been limited not by any technical limitation to go into the wet season. And exactly what defines the wet season in the area we are is an interesting question. We're far enough south that we're not likely to see cyclone activity or very serious storms. So we're far enough south that the highest risk we see is damaging pastoralist roads. So we don't want to see or stranding equipment at the end of a road that we don't want to damage to get out of. So we've sort of made a very purposeful decision at the moment to avoid that risk entirely by operating during certain windows. Now, if we did go to a full development scenario with the year-round operations, we would put the civils engineering in place prior to the season of operations such that you could have year-round access. We don't anticipate any specific problem with the wet season that couldn't be handled. The obvious one that we would reflect that we're there to look into is how to manage enough freeboard in any open storage, or you could go to an entirely closed system potentially. And I think if you're on a pad operation where you're drilling 8 wells and it takes 6 months, and then the fracture stimulation operation takes multiple months as well, investing in that centralised facility is a way to remove that risk of receiving large-scale water. I mean, the highest annual rainfall at Daly Waters Airport in a year is 1,182 millimetres, I believe. And the Bureau of Meteorology's frequency, intensity, duration, 3-day period event is about 380 millimetres in a 3-day period. So the long data source that we can use to put a safety factor and design factor around any storage. And I know that other industries in the Northern Territory, the mining industry in particular, would need to handle similar challenges and in some instances much closer to areas of potential cyclone activity where it could be increased. Does that answer? Does that
I think
help?
so. So effectively, if I understood what you're saying correctly, and please do feel free to correct me if I'm wrong, is that you would you think it's sensible to have or a good idea to have a restriction for seasonal operation in relation to exploration, but not full-scale production and development?
Well, I think it would be if a proponent was prepared to invest in the civils in the roads in particular, such that they weren't damaged, there's no prescriptive reason to prevent the drilling and fracture stimulation activity. So there's nothing in the wet season that makes the drilling a different risk profile or the hydraulic fracture stimulation a different risk profile. So I think for year-round operation, it's really a balance of, at the moment we balance expenditure versus the scale of project that we're in. So investing $4 million in a blacktop road into a site versus waiting 3 months to access it after the wet season is the proposition that we have. We only have a couple of wells to drill per year. So the right rational sort of logistics decision is to wait until you don't need to invest in that very high level road, because during the dry season it's perfectly passable. So it's very much around that access piece, if you're away from the highway in particular, that drives our behaviours to date.
To the extent I may have read something different in reported in the paper that's perhaps was taken out of context.
Yeah, I think I've read the same summary, and I did do an interview with ABC where they put that question to me directly after the interim report. And I said my response, as I recall, and I think the transcript is there, is that we believe an objective-based risk regime is appropriate for any kind of operations, and then went on to expand that if we went to wet season operations, we could go to a fully enclosed system, for instance, that would reduce or remove that risk entirely. But if we weren't able to operate in the wet season for some reason, it wouldn't necessarily prejudice the commercial possibilities of the project. It may not be optimal, and we wouldn't necessarily suggest it should be prescribed.
Oh, I see.
But it wouldn't necessarily mean you can't go ahead. But it's all about the trade-offs and the economics of what different costs would impact.
Trade-offs to social licence and things like that. All right. The well density, there seems to be a lot of confusion about, I appreciate that you have given us your best estimate at this stage for the area that you're looking at, but obviously you're aware of, I think, a departmental estimate of up to sort of 6,000 wells.
Yes.
Do you have any idea, can you explain in any way the vast discrepancy between your estimates and those of the department?
A fundamental different view on what the market could be and how you would access that market. So we're as a fully integrated energy company that has a lot of interest in pipelines, we are pretty in tune with what's possible, what's feasible. We don't anticipate that higher number is an economic proposition to a pipeline company in the current environment. So we would not see sufficient pipeline capacity into that basin in the time frame, a reasonable time frame to consider for economic modelling that would allow that type of development to occur. So we just see that there must be some kind of fundamental difference about how the expectation of where that gas is going to go. I think what is in the interim report, which is a combination of a couple of different components, is probably about the scale of what could be reasonable. Is it likely to see 2 of those pipelines going in? It doesn't, I don't see people clamouring to build a second northern gas pipeline. So
Not at current
I
cost,
think the
no.
reality is that the higher end it would be stranded gas. So the discovery may support a much larger number of wells, but we have 30 TCF discoveries in the North West Shelf from the 1970s that still aren't commercialised. It would be similar to that.
You've correctly, last question from me before I let the panel loose on you. You have correctly identified and spent some time on well integrity, and you would know that this comes up time and time again in consultations, and I think quite a valid point is made by the community, which is, well, to quote you, Dr. Close, nothing lasts forever. And people are quite concerned, and we are concerned about, well, not having adequate data going forward, say 50 years, 100 years, 500 years, whatever that may be.
Yep.
What's your response to that?
I'll let Alex, why don't you go first, Alex, and speak to that.
Yeah, so I guess part of the question would be around the materials that we select to construct a well with in the first place. So what I can say is that the materials that we do select are specially engineered to be able to withstand the conditions and the fluids that they'll come in contact with. One of the things we'll be including in our written response will be some literature providing evidence around the testing and the like that has been done on various cement blends to demonstrate their suitability for the conditions, pressures, temperatures, and time periods we're expecting these materials to last. I guess lastly, what I would sort of put again is just because there's, in a very worst case scenario, just because there's a pathway, again, doesn't necessarily mean you're going to have migration or a contamination event. You do need the ability to push a fluid, be it gas or liquid, from one spot to another. Unlike areas in the U.S. where, in I think Dave's South Texas example, where you have 10, 12 different tight or conventional gas reservoirs stacked on top of each other, which prevent substantial challenges, and operators in those areas have been able to overcome them. We have a very limited number of hydrocarbon-bearing zones, 3 to be exact, none of which are conventional of nature. So the ability for fluid to migrate is substantially lower than in other areas, which is to our benefit. That is not to say, again, we will construct these wells as if they were a well that was going in any other play in North America, Europe, Australia, to be able to handle time.
Thank you. Sorry, one last question for me, I promise. In the jurisdictions in which you operate, both here and overseas, what, in your view, is the toughest regulatory regime? The most onerous? The most expensive, if you will, to comply with?
Queensland has a very thorough and recent regime and heavily conditioned on the CSG projects. So I would put that is probably across the board comprehensively, mostly so. But I'd have to check more broadly with colleagues around if we want to do some kind of comparison with New Zealand, South Australia, Western Australia, Queensland, and there probably isn't a simple answer. It would depend on different elements of how industry is regulated. In New Zealand, there is already independent assessments of well integrity, similar to the North Sea, for instance. So that's one element that's more onerous than in other instances.
That's a fair response, which is it does depend, I think, on which component you're talking about. Yeah. So I noticed, for example, earlier, I think Alberta, one of the Alberta directives in relation to well construction was quoted.
Yep.
Right. I will start this way and go down. Yes, Professor Priestley, thank you.
Thank you. I have 2 questions, one of which you may have already been in the process of answering, and the other one is a new issue. The first one, in your original submission, you made reference to a risk assessment being done in the Beetaloo Basin. This was referred to in part 7 of the questions that were referred to you. I got the impression that we're still waiting for that health risk assessment report. I wonder if you can give us an indication of when it's likely to be available, because it would be useful to have that before we get too far into writing up our final report.
Yeah, look, certainly we are in detailed drafting and revisions, and it's mostly around providing some of the context. So I think we can expect to at least give a summary and the data part of it with our written submission, and the full risk assessment I would hope would be able to give at the same time. It is very comprehensive. We're working, it is one of the challenges over the next period of time. We'll be working with consultants that, along with companies, are dealing with data for the first time, and so to be very thorough about it does take some time. So it is still very much a priority, and it will be submitted as soon as
It
we
would
can
be
make
very
it.
useful to have that, because the methodology that I anticipate you'll be using would be relevant, I think, to what we're proposing as site-specific risk assessments. The second point I have relates to the issue of flaring, gas flaring. We've had references to the potential impact of gas flaring on communities, particularly for the Queensland situation. I understand that in Queensland that relates to CSG production, and while there may be some differences, there are obviously some similarities between those two forms of gas extraction, and in particular in relation to flaring, I would imagine there'd be a lot of commonality. Could you perhaps outline the approach that you propose to take to the management of flaring operations in shale gas operations in the Northern Territory? Where would the flares be located? What sort of frequency would you expect them to occur?
Yeah, happy to do so. First off, during the exploration phase, flaring is necessary to test the well. There's no infrastructure at the moment that we can readily tie into. So part of being able to assess the reservoir at this stage means that we need to flare. So during exploration phases where wells are not tied in, flaring is going to continue being the safest way for us to test the well. During production or development phases, what you'll find in most North American shale plays is you flow back in line. So that means essentially as soon as we start flowing back, you're flowing through your initial separation and your gas is going directly into the pipeline. So that means we still will we need flaring ability for safety during drilling operations and completion operations. In case we have gas that flows on us, you'll still have a flare that's required at a plant site and the like, but flaring as far as testing prior to putting the gas in line, I would anticipate that good operators should be able to eliminate that completely, that there should be a push to tie in line. That is what I'm familiar with working with other operator as well. That's how we operated. So inline flowing as soon as you're done stimulating the well would be the way that you would minimize flaring.
Okay, thank you. I guess the final part of my question, which I should have put first, is do you have any air monitoring data on what's emitted during those flare operations? I think that would be important to inform any health risk assessments.
So we definitely know the composition of our gas that would be flaring off. I guess there were past questions about what the actual efficiency of a flare is. So I guess that means, are we actually burning all the hydrocarbons that is passing through the flare system, which I can have a look and put a response back in our written submission, if that works.
I think Queensland is a reasonable analogue for what it might look like. You can now go online and see all the updates of air quality in a number of stations across the Surat and Bowen Basin. Not an unreasonable expectation there might be something similar in the future if a development was to go ahead, so that you could see any changes relatively real time.
Yes, Dr. Anderson.
Yeah, thank you. I've got questions over 3 issues that I'd like like to ask. And the first one is the spacing between well pads. And you've expressed a concern about any specification of minimum spacing between well pads. And so I just wanted to ask, so you showed us this photo of the Texan situation and how we wouldn't, wouldn't look like that, and I don't think anyone would like landscapes to look like that. But if well pads were at that density, they would look like that. And so I was wondering why the concern of setting some minimum distances, and if there weren't minimum distances set, how could the community have confidence that it wouldn't look like this?
And I guess it depends on scale a little bit. If it was to say that they cannot be within 300 metres, or I'm not sure exactly what the spacing is in that, it probably wouldn't see any resistance necessarily, but it probably wouldn't be a regulation that would have any impact. So if that was part of the overall social licence to operate, or what would make it acceptable, it may be something that would not be actively contested. I think if it gets out to the point where you're at the margins of what you expect you're going to be and it's prescribed, you are limited perhaps with opportunities of where it could be most optimally placed to limit the impact on the laneway system of a pastoralist, or a primary watering or yard of a pastoralist. And you would most likely be able to manage it, but there could be instances where it's not optimal because you are limited by the prescribed distance. And I don't see it meeting an objective. I think if the objective is to minimise overall impact, and you have a competent regulator or an agency that does your approvals, they should be able to challenge you on, well, is that an appropriate spacing in that area, and ask you to show why. And likely you'll see innovation over time that decreases it even further than what we anticipate today. So it's not an objection that I think we'd all stipulate that is not what it will look like and it would be economic on that basis, and we're not planning to do verticals. But if we start prescribing everything that can't be, it can become burdensome on all parties without adding a lot of benefit potentially. I don't know if there's anything, Steph or Alex, you think?
What about the benefit to the community
Well, I think
of not having an industrialised landscape, which we've heard time and time again as a concern?
The objective we would absolutely agree and stipulate on, but is that successfully achieved with, and it depends again on the exact nature of the number, if it is to be 1 per 2 square kilometres versus 1 per 15 square kilometres. So it would depend, like most things, it would depend on the detail of how it was going to be prescribed. And I think if it's to minimise impact, and for the direct rights owner to be particularly concerned over that, presumably who's part of that approval process, there are fairly strong protections in place currently, I'd suggest. Because approval would need to be given for each well. So I guess it's hard to comment without knowing the detail of what the proposal might look like.
Yeah. And just to add on that, with our developments, there is an asymmetry. So in the direction that we'll be drilling in, you would expect the spacing to be greater than the direction perpendicular to that. Our ability to sort of drill off and then forward is more limited than our ability simply to drill forward. So, so I'd agree with Dave. Better understanding of what the proposed minimum might be and how it might affect your ultimate pad spacing would be a benefit to us to understand as well.
And the second issue is to do with traffic levels, and we all know that fracking involves a lot of truck visits, heavy vehicle visits, and it's an issue for both amenity, and so normally when we talk about amenity impacts, we think of the land transformation side, what we've been discussing. But of course, another important part of amenity is for people, residents living on towns on the main highways, and in particular tourists who are coming up to experience the great iconic NT outback, and what they don't want to be doing is stuck in convoy after convoy of heavy vehicles. And so I was just wondering if you've modelled at all, done any modelling at all of traffic requirements associated with these scenarios and phases that you've shown us, and maybe if you could just take that on
Dr. Anderson, we haven't done modelling on a development scenario explicitly yet, but what we can share with you is the modelling we did for our exploration activity, which we submitted to the regulator, as well as consulted with the Department of Transport on and had them assess the number of vehicle movements, the type of vehicle movements, heavy vehicles, light vehicles, and over what duration window. We then also had to share that information with the Department of Tourism to understand if they thought that there was going to be any material impact on tourists using the Carpentaria Highway and the Stewart Highway. So we're very happy to share that information with you. In both instances, in terms of feedback from those two agencies, they deemed that level of activity to be marginal and not of concern, and subsequently endorsed our traffic management plans for that activity.
Well, thanks for that. And so that's for the exploration phase that you've done, but obviously if you're scaling up, it's going to be quite a bit different. So if you're able to scale up those figures possibly on your written submission, if you could do that, that would be really good.
We'll attempt to model that for you.
Yeah. And then sort of an associated question, and I don't know if you've given any thought to this, but one mitigation option possibly would be to use the rail network. And is that something that considered? And,
absolutely. Given the Darwin port is a pretty major existing port facility connected to a rail network that goes very close to our existing, to the permit edge, it would seem like a very logical way to alleviate, minimise cost and alleviate impact on other users. Much of the materials, such as casing and tubulars and so forth, will ultimately come out of steel foundries in Asia, and be one of the competitive advantages we have, say, over the US, is that we are actually close to a lot of those supply routes. So I think rail will be an important part of certainly a lot of the inputs that would alleviate that problem. But how to model that is something we're discussing with some of the people in our projects team, and we'll certainly work on coming back with a more detailed reply.
And my final question is something that the panel has just been alerted to recently, and that is this thing called radial drilling as an alternative to fracking. Now, is that something that you've come across? So we've read a conversation piece on this. That's all we know about it.
If it's what I think it is, and I have to I'll come back with a more thorough response. We're dealing with such tight rocks that the amount of surface area that we need to create in order to effectively produce the shale, you would never be able to achieve through a drilling technique. The only reason these plays are viable is the extensive amount of surface area that we're able to create to compensate for your 10 to the minus 9 permeability. So it's I will take a closer look at exactly the technique that they're suggesting, and I'll provide some commentary in a written response.
So apparently BHP has been involved in this.
I'll have to take also a look at what type of assets they're applying the technology to. It might be a play that has significantly higher permeabilities than what we're dealing with, but I'll happily take a look at that and provide some commentary.
Yes, Professor Hart.
I have four broad areas. First of all, the groundwater resource and what is known about it. You put up the commonly quoted recharge rate, 100,000 megalitres per year. But as you know, we put in the interim report that there's another couple of reports that go from 100 to 330,000. So question one is, do you have any additional information? That's come from the department, all of that information. Basically, it's been redone and redone by various consultants, but it's essentially the same information. I can't find anything at all really about the age of the water, which is related to recharge. Nor can I. We've got information on the passage, the northern going across the Roper and also to the Daly, but nothing in terms of rate of passage, which for the Roper people particularly, and we've just had some presentations on that area, the importance of the springs and the Roper River and so forth. So that's a crucial question. I seem to recall some information that we got, and I I haven't been able to pinpoint it, but it's of the order of 300 years. But if you've got any information on that, we'd really appreciate it.
Yeah, I think most of our information is in the Napton and Fulton study, which
Yeah.
did summarise
Yeah.
a lot of that. And a lot of the source data, as you say, is that Northern Australia Sustainable Yield Project by CSIRO in
Yep.
2009. We do have a reasonable head map across our permit areas. That's about over 100 kilometres south to north. There's about a 3 to 4, depending on whether you're on the edges.
Say that again?
Across our permit,
Yep.
the head range is about 3 to 4 metres.
North to south. So down to Elliot?
Higher towards the south, lower towards the north, so supporting that northward flow in the Cambrian limestone aquifer, but a relatively low head compared to, say, we recently saw some data from Katherine and the head between, say, just a bit, obviously a bit of work going on at the moment, between Tyndall and the Katherine River, with quite a high head over a relatively short distance. We see a relatively low head over a far larger distance, so we'd expect our transit times to be much lower than what we're seeing in this region. That's very much one of the focuses of the CSIRO studies. So we are looking to find well pairs, which aren't that easy to find, that would be appropriate for tracer studies to try and start. And it might take us a number of years because of how slow it is. So I suspect in time we'll drill a purpose-built monitoring network for understanding the groundwater baseline. And it would take a multi-year study to start getting the real data to answer that question. I guess what we can say, it's not faster than X, because we would see that more rapidly. So it is on the order of the hundreds of years. And certainly Napton and Fulton interpreted most of the recharge for the Roper River, and I think there's other studies by the department show a relatively limited radius around the Roper River where recharge comes from.
That's true, but if you take the 100,000, almost all of that information is in the northern part of Beetaloo, and we haven't been able to find anything that relates to potential recharge in the southern part, and it's got to be less. I mean, the rain...
It isn't that far. It's not a substantial difference between Elliot and Darwin.
It's a substantial change in the rainfall load.
Okay, I'll have to go back to my BOM maps.
Okay, that was the first one, but we see that as an important set of uncertainties. The second question that I have relates to the reuse of the flowback water. Thank you very much for the updating. It's been all over the place in terms of the potential. So I think it was 90 to 100% that you suggested was in your ballpark anyway, which is...
Correct, of the return fluid that we're able to recycle.
Sure, which is very good. Two questions I have of that. Is there a need for any treatment of that flowback water before you can reuse it?
We took a sample and we tried to make the exact same fluid, the same properties that we used, and we didn't have any issue creating a cross-linked fluid. One of the questions moving forward will be, do we continue with a hybrid design, or do we move towards a slick water design? There was very specific reasons we had to go with a hybrid design. Part of that was down to the wellbore design. As far as the salinity values weren't high enough to cause us an issue. Keep in mind also the flowback water would need to be blended, or would be blended to supplement back up to the volume that's required. We believe that if we were just to use the flowback water that we recovered at a Mungie, and if we were able to get enough of it to do a whole stimulation job, we could simply use that fluid. The fluid's properties will only improve once we start blending it back down.
So presumably there's a minimum time that you can keep recycling, reusing.
So once you get too many total dissolved solids and stuff in there, typically what will happen is you'll have a series of retention ponds and you'll move water from one to the next. So it's fairly, in plays that I've worked in, we haven't needed any elaborate filtration systems or anything of the like. Usually time and settling was our strategy of choice.
Shandying with other types. Shandy, mixing.
Oh yes,
with other
yes.
possibilities. Sorry, that's shandy. Third one relates to hypothetical of I know what you've said about the low, from your perspective at least, the low risk of contamination of an aquifer. But let me put to you, if it does occur, what remediation methods do you have available to you?
I think the specifics of the event would be important. So,
agreed.
Yeah, so a surface spill of flowback fluid versus later in the production's life cycle where methane is your only really available contaminant. Methane, if you did detect that there was any stray methane, you would still have, if it's in a producing phase, the ability to P&A that well, squeeze cement, remediate that well. So that would be, and the methane over a relatively short period of time would have a short life in the aquifer because it's highly mobile and it's buoyant. So it would there would probably not be anything else required other than that time. With flowback fluid, it's most likely going to be not aquifer. It's hard to comprehend the scenario where it's an aquifer contamination event rather than a surface soil and near surface event. You would, depending on the scale, put the right monitoring in place. Either look at what the extent you expect it to be if it's mobile, is removal and or treatment of the material the right action at that point.
Removal? How?
Well, if it's a soil-based event, depending on the scale of the issue,
What
it would have
about
to migrate very quickly to be an issue into the groundwater. If it did make it to the groundwater, the front will have expanded substantially, such that assuming the dilution is reasonable, and again it would depend on exactly what we're talking about. If it was flowback fluid, I think that would not, from what we've seen, there would not be no lasting environmental legacy from that. Obviously, if you had a sustained problem across a development, that would be an issue. But if you're talking about a single one-off incident, we don't expect that would create any kind of environmental legacy.
Okay, can I just one more? Yep. Yep. So I've got a couple on the wastewater, which is what we've been talking about, flowback water. So just going back to what you said before, which worries me a little bit, because if I can paraphrase it, you say dilution's going to fix it. Dilution's the answer to pollution. I don't know whether you meant that, but that's the way it came over to me. I think that that depends very much on... So what are you going to do? What do you anticipate doing for the monitoring? Because that's the first thing. You've got to know it's there. And it's presumably... That's why I asked a question about the flow path and the rate of flow paths, because if you're right about the dilution, that is very much tied up with that you've monitored downstream, down flow path, and that there's enough flow that you will in fact get dispersion. So I see a number of issues there. Look, you don't have to answer now, I appreciate that, but certainly if you take that on board.
Yep.
And
I think we are doing some detailed modelling based on your RFI at the moment to look at what it would look like in terms of a plume if you had an event at different scales. So
exactly.
I think whether it's a pipe for us to not know what had happened, we have to put any kind of time lag, we'd have to think of a scenario where it could occur without immediate knowledge. We can just assume that gap exists for the purpose of length.
The reason I'm asking you, and I asked Santos too, is that the contamination of water, use of too much water, but contamination of groundwater is absolutely key on everyone's mind. And so we want to get as much information as we possibly can from the companies as to what they potentially can do about it. Nothing or lots. Okay, you put in place all of the methodologies to ensure it doesn't occur, but as everyone knows, these things do happen at times. So what can we do about it? So that's why I'm...
It's particularly concerned with decommissioned wells. So time and time again the question is asked, well, look, okay, well's been decommissioned. Let's say that, hypothetically speaking, there is a failure that results in methane seepage into the aquifer. How do you, monitor to see whether or not that is occurring, and if it does occur, what happens?
I think we have a better understanding of what you're asking us to respond to, and we will include some scenarios in surface spills of frac fluid, a diesel spill at surface, how you would deal with that, as well as potential contamination through the pathway of the wellbore, and get that back to you in writing.
Okay.
Thank you.
Thank you.
That'd be useful, including monitoring. That's quite critical. Thank you.
And the last one I had, again on the wastewater, you've gone through, and you'll obviously go through a lot more detail in terms of collection, storage, treatment, potentially, and reuse. What I wanted to ask was whether there's been any discussions between the three players, you, Santos and Pangaea, about a coordination of... I'm thinking probably more about if there's a component of treatment. Doesn't seem to me, given that it's only, a couple of 100 kilometres or thereabouts, whether there's a potential for some coordination.
Yeah, look, I think we have certainly had high-level conversations, and if we were to be moving towards projects where that requires a solution, I think it would make sense. I think the industry has moved on a long way from the 2010, 2012 time, and would look at ways to minimise overall impact, optimise the cost for the proponents, plus make it more efficient and less impactful on other landowners. So I think you're right that there's considerations around having fair contracts and having people be able to work, not creating a cartel effectively. But we will work through that to try and come up with a sensible solution. Anything you add?
I thought I'd just say that you also have to balance other items out. The additional pipelines that would be required, or trucking to move things to central facilities versus individual facilities. So it'll probably depend on exactly what that treatment scenario might look like.
Absolutely. Yep.
I know there are a few more questions. Are you content to stay and answer them? I'm just worried about... We would, but I'm also conscious that there may be forms of transport that can't wait.
No, I think we're more than comfortable.
Maybe 15 minutes.
That's perfect. Excellent. Dr. Beck.
Of daylight hours.
Thank you very much.
Get home safe.
You've opened the gate. A couple of questions. We've heard repeatedly that Australia is awash with gas. The implication being that why do this development? In at least one of the presentations at the hearing, information was extracted from a recent AEMO report to demonstrate that Australia is awash with gas. Can you enlighten us, the panel, as to what the situation is from your perspective, so that we understand the details?
Yeah, look, I think it is a confusing subject matter area, because we hear daily of, is there a supply crisis, and others who would suggest that we're, as you say, awash with gas. Clearly, the supply and demand gap has tightened. I think that's no secret. If there was a readily available gas resource to expand quickly, I think we would see that happening. And if you look at the East Coast market, there hasn't been any more resources rapidly being brought to market. So I think that the answer lies in that free market. Over time, you would expect the market to respond. And there was always going to be a longer-term transition as Australia became an exporter from the East Coast as well. We had decades of a relatively low, artificially low gas price that wasn't sustainable through necessarily the transition that was foreseeable, that was foresawn. So I think there is definitely a place for Northern Territory in the long-term supply security in the East Coast, because there aren't that many remaining large-scale resources that could be added to the mix in Eastern Australia over the coming decades that we know of today.
Will you be able to furnish us with some details? Because Origin and others are obviously looking at the potential development of the Beetaloo, but others are telling us that we're awash with gas. So as a panel, there's conflicting messages coming, and if you could help provide some documentation that would either reassure us or whatever,
Yep.
we'd be most grateful for that because, as I said, one starting point was data that was extracted from a recent AEMO report.
Yep. So I'll certainly come back with what might be Origin's position
Yes.
as both the retailer, wholesaler, generator and explorer, and give a position on what we think that
Yes.
reflection on that.
That would be most helpful. Thank you very much. Second question is, based upon that same AEMO report, it said, it was reported to have said, that the gas from the Northern Territory is going to be high-priced gas at $7.50 at the wellhead, and by the time that you add transport costs and so forth onto that, then NT gas will be blown out of the water, was the implication.
Yep.
So again, why are we going through this exercise?
I think there's a range of outcomes that are all potentially in front of us, and that could be that Northern Territory shale gas is not competitive with other sources of gas in the market, whether it's North West Shelf coming through a pipeline network, or whether it's marginal Queensland CSG plays or expansion in the Bass and Gippsland basins. I certainly don't know that answer. I think there are, on the possible range of distribution of outcomes in front of us in the Beetaloo, there are a suite of those where it could be marginally economic, and there's a suite where it could be very economic. And until we have further data to really understand what an individual well can deliver and what that individual well costs, that would overcome the transport cost differential if it was of sufficient quality. So I think it's a really good question, and we hope to get enough data to be able to put a really detailed case together about what the economics look like, and to get funding for that project, you would expect to be held to that level of thoroughness.
So at what stage do you think you would be in a position to have that internal information to make a commercial decision?
Look, I think at the moment we'd hope if we were able to start doing further exploration and appraisal, that you may, if in a high success case scenario, within 2 to 3 years, know that it was clearly going to be successful. If it was, it could take 3 to 5 years if you're in the range down where the rate of return is less clear.
Yes.
So I don't know that you, again, would know for sure what that time frame looks like, but I think the interim report used a time frame of about 10 years before you would see gas. I think that's a reasonable starting point, and we would support that kind of time range.
Making commercial decisions. It's
Back
going to be
from that,
early.
Indeed.
Okay. Now, another question is that you've...
I think Dr. Ritchie also has a question as well. So,
you mentioned the analogue with the Marcellus field, and the test result from Amungi was, I think, initial flow of can't remember the figure.
Just over 1 million a day.
You can refresh my memory.
Yeah, a little bit over a million standard cubic feet a day.
Million standard cubic
Terajoules a
feet
day.
per day, if I think it was. Now, in terms of, this is now a question on speculation, the Marcellus field is currently delivering, I think, about 4 billion cubic feet EUR, and clearly there's a big range in that. Are you prepared to speculate on the EUR out of the Beetaloo Basin on the basis of your one test?
Well, yeah. And we were quite cautious in our ASX release,
Yes.
not to try and forecast exactly what the EUR of an individual well would be if it was a development well, because that's quite sensitive information, particularly for our partners. So I think we see the technical parameters being not dissimilar to plays like the Marcellus or Modney in Alberta, such that the range of outcomes that they are able to achieve today would be, if we are in a success outcome, a range that's not unreasonable for us to anticipate.
Right. Okay.
It's a little bit
So-
of a roundabout
yeah,
way.
okay.
And by analogue is our bet. With one data point, analogue is our best way There's lots of ways. If it was less than that, if you can't, less than some threshold, it wouldn't be economic. And the detailed modelling of that is not that interesting.
Yes, okay.
Thank you. Yes.
Thank you.
Thank you. Dr. Ritchie.
Thank you. Look, given the time, could I ask that you provide us with a detailed explanation and just take us through the processes that you've engaged with the Northern Lands Council and the Areas Protection Authority to assure that you have all the approvals in place, and that your assertion to us today that you have consulted with all the actual owners of the land, native title holders, or traditional owners in the form of if it's on Alra land. Because that's another point that's been put to us that hasn't taken place, and I think that could be cleared up quite readily by a written advice. Thank you.
Dr. Ritchie, by detailed explanation, will you be satisfied with us responding in writing with a detailed timeline of all our meetings and engagements and what the contents of those meetings were?
Yes, that would be what you'd call the sort of factual material that would accompany an account of what you think you're actually doing in that. In other words, what are you're engaging for, say, the negotiation of an ILUA, you're entering a negotiation to get approvals under the Aboriginal Areas, the NT Sacred Sites Act, whatever you believe are the things that you're doing to ensure that you have the approval of the traditional owners of the land.
We'll respond in writing, but we can generally share with you that each year we have an on-country meeting, and the intent of that on-country meeting is to come back and report to traditional owners, and typically we have about 100 to 120 people at that meeting, the previous year's activities, as well as discuss and get consent on the activities to come. It's not the only meeting. There will be 6, potentially 8 meetings throughout the year with the Northern Land Council that are typically in relation to cultural heritage clearance work, as well as confirming well locations. So we go to traditional owners with a potential suite of well locations. There may be 16. They'll immediately tell us that 8 need to come out, 2 need to come out, or all 16 are inappropriate and not allowed to be used. That's why what we talk about by co-design and co-planning. Cultural heritage surveys are done, NLC report. We then go to ARPA for certification before any activities take place. But we will comprehensively detail that process for you for 2014, 15 and 16.
I guess it's just, I'm assuming that you believe that you already have some approvals in place as a result of that. It may just be of interest that the information that we got from ARPA, for basically your applications for authority certificates, they were for vertical drill holes and well pads. They didn't actually mention at any stage that you're actually applying for a preliminary to a next program of hydraulic fracturing. So in that sense, the information you provided to the statutory authority didn't include actually what you were proposing to do in the longer term. So the same applies to everybody. Nobody did in your industry, but it's just something perhaps you could address in your submission.
I am fielding requests from other panel members for more questions, which I am in my capacity as chair declining, but I take it that you won't be adverse to those other questions being put in a writing and being sent to you. Thank you very much. Thank you very much for giving up your time and coming and presenting again. We have taken more than was allocated. We're very grateful for your time and engagement with the inquiry. Thank you.